Welcome, everyone. Hopefully you are here to participate in the panel discussion about a new Linaro project, Windows on ARM. Participants of the discussion are myself, Mike Holmes. I'm a director in Linaro of the Performance and Enablement Organization.
Hi, I'm Marcus Perryman from Microsoft. I'm a principal engineer in the Windows team.
Hi, everyone. My name is Rami Hussaini from Qualcomm. I'm the Director of Product Management, leading the Windows on Snapdragon commercial and ecosystem strategy.
Hi, I'm Dave Whaley. I'm Director of Ecosystem Partnerships for the Client Engineering and Ecosystems team based in San Jose, California.
Thanks, everyone. So the first introduction question probably everybody wants to hear is, what is the Windows on ARM project and what are we doing to support Windows on ARM? From Linaro's perspective, this is really a traditional mission. We exist to support the ARM community. And in this case, we're working to bring together participants to address gaps in the upstream CI for packages that run on the Windows on ARM platform. Historically, Linaro has looked at Linux, Zephyr, etc. So really, Dave?
Yeah, so ARM obviously has been involved with Linaro for quite some time since the beginning. But we see this as a great sort of great new partnership on a platform where we're trying to build a new ecosystem, and ARM has been doing some work behind the scenes for a while. Could upstreamed Electron and CEF and some other things, but I think this partnership will allow us to expand and hopefully really make this a mainstream platform.
Yeah, Qualcomm is excited to be part of this partnership. We've had multiple generations of chipsets for the Windows platform, and really our goal is to really bring the best chipset to market for the Windows platform. Think of these devices as being always on, always connected with 4G and 5G connectivity. And what we're looking to do is bring new experiences to the Windows platform, bringing the best of mobile into Windows with all-day battery life through giving you power and performance that is unparalleled in the Windows form factor. And so think of these new experiences spanning AI, 5G, cloud connected compute that we'll be talking about in this session. And we're excited to partner with Linaro, ARM, and Microsoft to develop this open source community, along with the open source community to bring new experiences to the consumers.
Thanks, Rami. Yes, from Microsoft's perspective, of course, Windows being our core product for our edge computing on devices like Surface and our third-party devices, we obviously want a great ecosystem to be there for our users. That's really important because, of course, we can ship the operating system, we can impact the tools, and we can deliver libraries, but without the third-party experiences, it's not delivering the right environment for our users. And underpinning that, of course, is open source software, which is used by many of our third parties. And seeing partnerships created like this opportunity here with ARM, Qualcomm, and Linaro, and being able to support them in their efforts is very important to us to make the whole Windows and ARM experience successful.
So Marcus, Microsoft, as you just alluded, have worked with ARM previously. Why is this different?
Yeah, so we've got a long history of working with ARM processors. And that history gives us a lot of experience in understanding and working with the instruction sets and different chips. But when you look at today's landscape in the device landscape in the industry, there's been a large amount of investment and growth in the mobile space, which has been a fantastic place for innovation to take place in the chips and developments in performance and capability, to the point now, and also in form factor for the devices. The various different form factors have changed and have blurred the lines really between different devices, traditional devices that we would see, to the point now where the ARM core processors are very capable of delivering an exceptional desktop experience, but they also bring with them a lot of those new developments around power consumption or battery consumption, which make it a fantastic choice for developing new device form factors, as well as taking over the traditional space as well to provide a lower power form factor of device. So we're in it for the long haul. We always have been, and we see this relationship continuing into the future as we develop through Windows 11 and beyond.
Thanks. So I'm guessing developers watching this are going to wonder, will my app still work on Windows on ARM if I don't recompile it for ARM64? And they're probably curious about any edge cases.
Sure. Again, let me take that one. In terms of Windows on ARM, the work we've been doing over the last few years has been exactly that. When you pick up a new device that runs the ARM chip, you expect, the consumer expects all of those great experiences that Windows is known for, that ship from our third parties, from our partners, to just work. And so it's a really important piece of the Windows and ARM ecosystem to enable that with minimum effort from our developers. And so as a baseline, the piece of work we've been doing is to support emulation. And in the existing devices we have today in the existing operating system, your x86 application will work without change on Windows and ARM using our emulation platform that's built into the operating system. And when we look at our Windows 11 platform, which is out this fall, that also brings with it x64. So Intel 64 instructions will emulate on that device. And there's a new hybrid called ARM64 EC, which actually brings a great place to start bringing both emulated assemblies and native assemblies into the same process to ease the steps of migrating. So that provides our baseline. That gives us what the consumers expect when they pick up the device. Applications just work. You mentioned edge cases. Let me just talk about that. Yes, there are. So the emulation is for user mode applications. When we start going into the kernel, emulating at that level is fairly tricky to do. And so kernel level doesn't have that emulation. So if today you have a kernel level driver, user level drivers can be emulated, kernel level drivers can't. So if you have a kernel level driver, then you will have to port to ARM64 native code for it to be loaded on those devices. So those are the primary edge cases that you'll have.
Great. So you mentioned that there's this basic emulated platform that's going to make these apps work. So what's the value of converting an app?
Yeah, so when we think about the emulation, it is a baseline. It's intended for that. It's to give that base functionality. But the promise of ARM hardware that we're seeing from these new chips, from the Qualcomm chips that we've got, is battery life, is fast performance, long battery life. And in order to get that, we have to move away from the emulation platform because, of course, emulation is more expensive on the chip, uses more instructions, and is less optimal. So it's been not built specifically for that instruction set. So the advantage of moving across is that you will get a step in performance, and more importantly, you'll get a step in battery. And that delivers that promise of all-day battery life on these Windows and ARM devices. So it is important that we're all in this together to get that promise delivered to our consumers. We do need applications to take the step of moving from emulated to native execution. But there's more you get with going to native execution. And actually, maybe Rami, you can help us explore some of those areas.
Yeah, thanks, Marcus. Yeah, really what we want to do is deliver that best app experience to our end customers. That's our main target and goal. And to echo what Marcus was saying, one of the things that really comes out of these platforms is the all-day battery life at the high level of performance. So in order to get there, you definitely want to port to native, and that way we deliver that best app experience to our customer. But taking it one step further is these Snapdragon SoCs. They're essentially a system on chip where you can distribute workloads from the CPU to specialized cores. So there's an AI core it's called the NPU that includes a Snappy SDK. And with that Snappy SDK, you can actually tap into that AI core and run all of your AI workloads on that. So it'll do all of your tensor math. It'll do all your vector math on that specialized core. In addition, there's also a camera image signal processor called Spectra that will handle all of your image signal processing, as well as your video cores. So how does that all bring it together? Imagine this video call that we're on. So you've got your AI workloads like virtual background or background blur that can run on the NPU. You've also got these video streams, which can run on the camera ISP as well as the video cores, while your CPU is kind of handling that general purpose processing, along with 5G running if you're kind of out in a mobile environment and need that connectivity. So by having that distributed workload across the different cores, it really allows the application to provide that best experience to the end users by distributing the workload. So really looking forward to this partnership with app developers to work with them to kind of bring that experience to our consumers and really showcase the platform. Hey, Dave, would like to hear about it from your perspective as well from the ARM side.
Yeah, I mean, I think there's been a lot said here, and I can add a little bit, but obviously the emulation side is very capable, but it is emulation. So we've been working with app developers to do things like supporting app frameworks, try to get as much of the goodness of ARM out there as possible. So things like Electron, that is the baseline for many applications that you're familiar with, CEF, that sort of thing. So we really see that when you have ported an app over to native ARM, Windows on ARM support, you're seeing better battery life, as you said, better load times. It's just a better experience for the user, and it's really taking advantage of the platform. So anything that we can do to help support that is really what myself and my team, that's what we work on.
Thanks, everyone. So Rami, if I could direct this at you, you've done a lot of work with application developers already. Can you give us some insight where things stand today?
Yeah, thanks, Mike. If you look at Windows on Snapdragon, it was first introduced in 2017, and the adoption has been incredible. Having worked with developers, you could look at their development life cycle as kind of being a few chunks, right? First is obviously they have their standard tool chains that those developers either use Visual Studio or LLVM to compile. They might have third-party libraries. They might need technical support. And then, of course, at the very end, they'll need a test to make sure that their app works. And I'm here to kind of share that we actually have solutions for all of those. So when you look at the tool chains, Visual Studio is actually optimized for building Windows on ARM apps, right? LLVM was recently also released a version of their compiler that will also compile Windows on ARM apps. So from the toolchain perspective, we have a comprehensive solution. From third-party libraries, if you depend on third-party libraries that are native, that's fantastic. But even if they're emulated with Windows 11, you get the ARM64 EC that allows you to run those in emulation while your core components run native. Also, from the support side, we've partnered with Microsoft's App Assure team, who has a big support staff of engineers ready to support app developers with technical questions along the way. And then from the testing perspective, you have Windows on Snapdragon devices, both from standard commercial devices like the Surface Pro X, as well as the developer kit that we're releasing here over the next several weeks that will be a low-cost platform to do testing. So bringing all that together, as we've worked with developers recently, the port to bringing those native experiences has been a quick lift. It's been actually relatively quick and simple to get there, given that all these components are in place. And they've seen the value that it brings the end customer, both from the battery life and performance, as well as those AI and camera optimizations that I referred to earlier. Hey, Marcus, would love to hear kind of from your perspective on the Microsoft side on how you think where things stand today.
So not really much to add to that in terms of where we are in the developer tools, apart from supporting the work that both Qualcomm and ARM are doing in this space. Actually, Dave, maybe you want to talk to us about what ARM's doing.
Yeah, so I mean, I think the open source community is where ARM can make the greatest impact. Like I said earlier, we had upstreamed Electron support, CEF support. We've also contributed a native build of Chromium. I think we see that there are, we actively go out and talk to developers, see what they're using, what they need. That helps us come back, to this group and prioritize the work that we see needs to get done. There's things like Fortran compilers, math libraries, all these sorts of things that we need to get done. Also another thing that ARM does is we maintain a pretty extensive set of articles, case studies, porting guides on developer.arm.com. Sorry for the pitch there, but yeah, I think there's some interesting things there. We have some case studies of people that have actually done the work to move to native, to a native Windows on ARM app. You get to sort of see, what their journey looked like, relate to that. But I think there's quite a bit of, quite a few resources out there for you to look at, and we've been at this for a long time, and I think that we've made some pretty good headway.
Thanks, everyone. I think we have to pull this to a close. So I guess there's a question. What is the call to arms for this project? Maybe you could kick us off, Marcus.
Yeah, sure. Happy to do that. Let me just take a little step back. First, the Windows ecosystem. So Windows itself is available on about 1.3 billion devices today, and the growth of ARM, ARM-powered hardware, Qualcomm-powered hardware, is good and has that potential. I mean, today we have Qualcomm-powered devices from Lenovo, Samsung, Microsoft, Huawei, HP. There's a number of manufacturers out there, and we're going to take another step change again with Windows 11 shipping with Windows on ARM from day one, which is going to be fantastic. So what is that? Well, there's the potential growth opportunity, which is huge. It may not be today, because today we are in the embryonic stage, but we see that as the opportunity. And now is the time to get involved. It's the right time. We've got that mass of devices. We've got the release of Windows 11. We've got the community coming together through this arrangement with Linaro, ARM, and Qualcomm. And if you have applications, so my call to action would be, if you've got an app today, or if you've got an open source project which is used by others, which is even more important, then it's time to grab the tools to take a look at how your application builds for Windows on ARM and see what the experience is like. There's everything you need is out there. Emulation is possible, that's fine, but we prefer you to convert. And the tools are available for you to do that. So that's my call to action. Go and get started today and get involved in the community. Let me ask Rami. I mean, there's bound to be a bunch of more things.
Thanks, Marcus. Just to add to that, I think as Marcus was saying, the ramp and the projections and the volume are going to take off. If you look at a recent launch by one of our OEM partners, Samsung, they just launched a $299 device with 4G connectivity, running AI and all sorts of all the items that I had mentioned before. And to deliver a Windows platform with always on, always connected at those low price points, the volume is just it's going to boomerang up. So yeah, to call to action, I would highly recommend, as Marcus was saying, grab some devices, start porting. Once the developer kit is available, highly recommend purchasing those. Those are smaller form factor devices that you can kind of bridge together to run automation testing, and start getting involved in the community and start porting. As more of our customers start to buy these devices, they'll want that optimal native experience. And call to action, yeah, please go ahead and start kind of being involved in the porting activities, and feel free to reach out with any questions. As I mentioned, we have an entire support team ready to help with questions along the way. And I'm confident that you'll find it much easier to port than initially thought, given all the tools out there. So Would love to hear about, Dave, from your perspective on the ARM side as well on call to action.
Sure. No, I mean, I think we're very, very excited about the developer kit coming out. I think that's something that this community needs. Building an ecosystem is hard. We're overcoming a lot of obstacles, and I think that this is all good. But my call to action would be, echoing, Marcus and Rami, get started, compile it, see what falls out, see what dependencies you have. If there's a library or something that you need, feel free to reach out. It's something that we can potentially get to work on. If you're running into this, you're probably not the only one. And we can potentially, bring some resources to bear on that. So, take a look at the tools, get involved. Obviously, take a look at the developer.arm.com site. I think there's some resources there that'll help, at least point you in the right direction. I think that the time is now to try it. I think the benefits that you see with a native version of your app will be enlightening, and I think you'll see why it's the best way to go.
Thanks, David. I think there's not much I can do other than echo a similar theme. Linaro its passion is to support the open source use of on ARM devices, and the fact that this project exists shows that everybody's coming together to make this happen now. So the time is now, and if you have packages that you're interested in running on Windows on ARM, get in touch. Linaro is easy to find online. I think at that we have to wrap it. Thanks, everyone.
Thank you, Mike.
Thanks, Mike.
Okay, thank you.